Hello friends, now we are going to discuss regarding the array list, comparison of the array list and the linked list. So we are going to compare this both with respect to insertion, deletion and memory head perspective. So if you know regarding this, please let me know or let me know in the comment box. So let's get started. So if we consider the search operation, suppose consider the array list of length 50,000 and consider the same length linked list with the length of 50,000. So if you want to search the element which is at the 25,000 location in the array list, and we also want to search an element in the linked list which is at 25,000 location. So if we consider the array list, then searching operation would take same time as that we search for the first element, and when we consider the searching element at the 50,000 or 25,000 location, both the element will be searched at the same time. But whereas when we consider the linked list, the searching time for the first location and the searching time for the element at 25,000 location will be very different. The first one will be faster, and the element at the 25,000 location would be very slow. So this is the difference between array list and the linked list. So array list provides O of n searching time complexity in both the cases. At the at most or the worst time complexity also it provides O of 1, whereas in the linked list it provides O of n, that is n is dependent upon the size of the linked list. So next thing that comes is the deletion operation. When the deletion operation comes, linked list goes forward of the array list. Why it goes forward of the array list, you can see in the diagram. If you want to delete this element, what is the basic requirement that we will have to do is we will have to just manipulate the node element 5 and the node element 8. What we will do now, 8th element will start pointing to the 5th element, and 5th elements will start pointing to the 8th element. That's it, and you are done. This 4th element is deleted. But when you consider the array list, if you want to delete an element from the array list, then you will have to shift complete array list one by one, or uh, there is no any other another way that you can insert the elements in the array list. So this is the delete and deletion operation. So next comes the insertion performance. When we talk about the insertion operation, so insertion is also similar way. It's quite simple in the linked list, because just what we need to do is the changing the pointers from here. Now what will happen is the node 8 will start pointing to the previous of the fourth, and the next of the fourth node will start pointing to fifth node. The previous of the fifth node will start pointing to the fourth node, and the previous of the fourth node will start pointing to the eighth node. In this way we have inserted an element in a very simple method. But when you consider the insertion operation in the array list, there you will have to move all the elements ahead or backward, and then you will able to do the insertion operation. But it is a time consuming process. So if we consider the time complexity, so insertion in the linked list, it is O of 1, whereas the insertion in the array list, it is O of n. Now when we consider the memory overhead, so when we consider the memory overhead, so every node has 1 2 3 4 4 pointers which store memory address. So this is the memory overhead which we do not use in the array list. So this is the back point of the linked list. Okay, so when we consider we have already discussed the difference between the array list and the linked list. Now we are going to discuss regarding the similarities in the both of the classes. Both array list and the linked list are implementation of the list interface. So if you see in this diagram, so this is the collection interface. Collection interface is implemented by list, and interface is implemented by the array list and the linked list, and vector also. Vector is the older version. So this is the common method. So both of them inherit list. Then the next important point is both these classes are non-synchronized and can be made synchronized explicitly by using collection.synchronized list method. The iterator and the list iterator returned by these classes are fail fast. What is the meaning of fail fast? If the list is structurally modified at any time after the iterator is created in any way except through the iterator own remove or add method, the iterator will throw an concurrent modification exception. This is very important. You will be asked in the interview. So please get prepared for this. So now question comes, when to use linked list and when to use array list. As explained above, or as I explained in the previous few minutes, so when we have some insertion operations or deletion operations, we have a project in which we have multiple insertion deletion operations, then I would prefer going for the linked list. And if I want only the searching operation, we have huge database, and from huge database we are searching for the elements, then I would prefer going to the array list. So that's it. That's all for this video. Thank you.